Hello, in this session we will talk about challenges produced by big data and how Hadoop is addressing them. This is Hassan Mir from 0 to ProTraining.com. So from the previous videos we understand that Hadoop is a framework of tools and the objective is to support running of applications on big data. So why is that we require Hadoop to support running of applications on big data, how applications were run before? So in this video we'll talk about the challenges that big data is producing and why there was a need to create something like Hadoop. Now let's talk about big data. We understand that Hadoop is a set of tools that supports running of applications on big data. Okay, so there is no particular definition for a big data, but here are some attributes of big data. Big data is creating large and growing files on almost daily basis, and these files are measured in terabytes and petabytes. Terabyte is 10 to the power 12 and petabyte is 10 to the power 15. So we're talking about very large files. Where is this big data coming from? We're going to talk about that in a bit. Now, one attribute of this big data is it is unstructured. It's not an organized data in a relational database in nicely created tables that has columns and you exactly know what kind of value is going to go in this column. It is unstructured, okay, and that creates a challenge. Now, where is this data coming from? It's coming from users like me and you, applications like Facebook, systems like ticketing system, for example, sensors like in factories. So all these things plus many other are creating big data, and in other words they are creating large and growing files. So we understand that Hadoop is a set of tools that supports running of applications on big data. So the key word behind Hadoop is big data. Big data is creating challenges that Hadoop is addressing, and challenges are created at three levels. Lot of data is coming in at very high speed. Big volume of data has been gathered and is growing and growing and growing, and data is of all sorts of variety. It's not an organized data. It has audios, videos, files, log files, so on. Now, in a separate video, I have talked in detail about the challenges the big data is creating. Following attributes of big data creates challenge when it comes to processing the big data and when it comes to writing applications on it. Velocity, volume, and variety. The velocity is the speed by which the data is coming in. For example, 400 million tweets are done daily on Twitter, and 1 million transactions are handled by Walmart every hour. And this is creating a large volume of data altogether. So that would be a second challenge. Like velocity is one, the speed by which the data is coming in, and the total data is another challenge, the high volume. For example, 2.5 petabyte is created by Walmart transactions just in an hour. And variety is yet another challenge because this data, although it's coming with very high speed and it's creating large files, and this is not an organized data like relational databases store data in tables. This data is in all sorts of formats. Some are files, some are videos, some are audios, and even within the files there are a variety of files. The files do not have a standard format. Some files contain data in this format and some in yet another format. Here are some examples of big data: videos, audios, images, photos, log files, the click trails, text messages, emails, documents, books, transactions, and public records. Now we have talked about the big data. And okay, we understand that big data is creating large files, but now what is the problem and where does Hadoop fits in? Here's the problem. Okay, so the disk speed of a traditional hard disk could reach 60 to 100 megabytes per second, and now we have come up with a solid state disk. It's not a big breakthrough in terms of speed. As you can see, the speed now goes from 60 to 100 up to 250 to 500 megabytes per second. It is a breakthrough, but it's not as bigger of a breakthrough that we have done in other areas. Relative to the progress we have made in other areas, the speed of the disk has remained relatively flat. And the size of the data has been growing exponentially. So every 18 months, the data that we have collected doubles in size. And that is because so much data is being produced by systems, users, applications, and so on, as we have talked about. Here is a little perspective for you. So in 1990s, the capacity of the hard disk used to be about 2.1 gigabyte. Then in 2000, it was 200 gigabyte, and recently it was 300 gigabyte. You can go easily and buy about 4 terabyte hard disk from the market. And the price has been reducing as well. Now 1 gigabyte costs only 5 cents, and it used to be about $160 per gigabyte. And speed has been growing, no doubt. From 16 megabytes per second, we are about to 200 megabytes per second. And if you look at the time it's going to take to read the whole hard disk, that is quite interesting. Hard disk used to be a 2.1 gigabyte, and it's going to take about, it was taking about 126 seconds to read the whole hard disk because the disk was small, the speed was slow. But the disk size has increased, speed has increased as well, but not to that extent. Now it takes about 4 hours to read the whole hard disk. In the big data world, 1 terabyte file is a very small file. There could be many 1 terabyte files. A traditional hard disk will take about 3 hours to read this file, about 10,000 seconds, and a solid state disk, which are very expensive, would take about 2,000 seconds or 33 minutes to read this file. Like if it's taking you half an hour to read one file and you have tons of these files, then obviously it's not going to cut out. In a traditional approach, an enterprise will get a very powerful computer and it will feed in whatever the data is available to this computer to crunch the numbers. And this computer will do a good job, but until a certain point, a point will come when this computer will not be able to do the processing anymore because this is not scalable and the big data is growing. So traditional enterprise approach does have its limitations when it comes to big data. Hadoop takes a very different approach than the enterprise approach. It breaks the data into smaller pieces, and that's why it's able to deal with the big data. Okay, breaking the data into smaller pieces is a good idea, but then what? How are you going to perform the computation? It breaks the computation as well down into smaller pieces, and it sends each piece of computation to each piece of data. So the data is broken down into equal pieces so that the computation, these child computations, could be finished in equal amount of time. And once all these computations are finished, then their results are combined together, and this is what is sent back to the applications as a combined overall result. The purpose of this video was to explain you the challenges that are produced by the big data and how Hadoop is addressing those challenges. For the details on the architecture of Hadoop, that consists of MapReduce, file system, and the projects at a very high level, please take a look at my other videos.